So vanakkam. So we will continue our class on concept of earthquake quantification. Okay. So this basically we discussed that the earthquake can be quantified two way. One is that intensity, the another one is magnitude. So if you recall the first part of the intensity discussion, so we have discussed that the people have written a magnitude and then also they written a moment magnitude, and also I told you that the magnitude can be different for different wave type which is used. So when this magnitude concept come into picture, okay, so how the magnitude quantification has been started in the engineering seismology, and what we practice today is we are going to discuss in this class, and followed by, so there is a so the energy released from the different earthquake and what type of magnitude, how it is there, all those things we are going to discuss in the today class. So the magnitude is basically the size of the earthquake that are to be compared worldwide. To measure is needed that does not depend, okay, as does intensity on the density of the population and type of construction. So as we discussed that the intensity scale, for example, the intensity earthquake occurred in the forest region, there is no people, there is no construction, then the intensity scale is nowhere reported or it is 0, okay, but actually the earthquakes are occurred. So such the intensity is actually the function of the number of people living there and number of houses and construction type in the region. So this kind of things are bias. For example, the same earthquake occurring on Bangalore, the same earthquake occurring on Mysore, the same earthquake occurring in the somewhere North Karnataka remote village, okay, so will have the different intensity because of the population and type of construction practiced in the these places, even though the earthquake may release the same amount of the energy and the same magnitude. So this has been identified by the scientists, and then they started thinking how to overcome this. A strictly quantitative scale of size that can be applied to earthquake in both inhabited and as well as the uninhabited regions. So habited and uninhabited regions, so that it can be commonly give the same magnitude of value. So it was realized by the Wadati in Japan, and then they developed by the late Professor Charles Richter in 1935 in California. Okay. So the Charles Richter first thought about this and come up with the idea called magnitude. So this scheme is use a wave amplitude to measure in the seismograph. Okay. So we know that seismogram can record P, S and L wave and R wave, depends upon the where seismogram. So he tried to use that and try to give you the magnitude. The idea is come from that. So generally the astronaut, what they do actually, they guess a size of the star, okay, by looking at its brightness. Okay, so how bright is. So so the brighter star is assumed to be a bigger in scale. Okay, so that is what they did. The similar kind of concept has been extended here to quantify the earthquake magnitude, okay, earthquake size in terms of magnitude. So this basically relate energy released by the earthquake, because the waveform is a function of how much energy released. Okay. So the quantitative measurement, the amount of energy released by an earthquake will be reflected in the waveform what you see. Depends upon the size of the fault that breaks. So as you know that the bigger fault breaks, you will get a higher amplitude waves. So then the determined from the seismic record. So that means if you want to estimate a magnitude, you need to have the recorded earthquake data. For intensity, you no need to have any such kind of recorded. You need to have the damage observation physically by going to the site or by getting the photos and try to understand. So these are all the two way you can estimate a intensity. So the Richter magnitude, basically a magnitude of the local earthquake as a logarithmic to the base 10 of the maximum seismic wave amplitude in 1000 millimeter recorded on a standard seismogram at a distance of 100 km from the epicenter. So here you should note that it should be maximum seismic wave amplitude, okay, in thousands of millimeter recorded at a standard seismogram at distance of 100 km from the epicenter. So beyond this kind of distance, you need to apply some kind of correction. Because the earthquake sources are located at all the distance from the seismograph station, Richter further developed method to making allowance for the basically attenuation of the wave with epicentral distance when calculating the Richter magnitude. So, an uncomplicated earthquake record clearly shows the P wave and the S wave and a train up Rayleigh wave, which is surface wave. The seismogram shows only the vertical component of the ground motion. It can only show a one component. So, now the Richter procedure for determining the local magnitude were followed. We would measure the amplitude of the largest of the three wave and then make some adjustment to the epicentral distance and then magnification of the seismogram. Then you will get a magnitude. So, that magnitude will be the Richter magnitude. So, what was the Richter were used when he was arrived the magnitude? Basically used standard Wood-Anderson seismogram, which was the oldest seismogram which was developed, and then has been a natural period of so many seconds. These are all the very important. The critical damping of the instrument is so much. Okay, the earthquake amplification factor is so much, how much the data is amplified. So, it amplifies the wave with the period between the 0.5 to 1.5 seconds, the wavelength of 500 meter to 2 kilometer. These waves are particularly interest of the earthquake engineering potential. So, the ML is the function of log 10, A is the amplitude, and then the A naught is the basically the calibration factor depends upon the distance. Okay. So, using this you can estimate what is the ML. The Richter scale was calibrated assuming that the magnitude of ML3 correspond to the earthquake distance of 100 kilometer distance. So, with a maximum amplitude of 1 mm, indeed log A0 equal to -3 for the distance D equal to this one. So, this is the way where the benchmarking has been done at initially by the Richter, which has been used for arrive with the Richter magnitude. So, how it works? You can see a typical waveform record of the particular earthquake. So, okay. So, this earthquake you can see. Okay. So, you can basically, so you can see the P wave and S wave, then followed by surface wave. So, this particular location, the P and S waves are very predominant when compared to the surface wave. So, as per the Richter definition, he says that maximum of this 3 amplitude, you can see that maximum can be obtained from the this particular place. So, you know what is the amplitude in the mm scale. So, which is basically this value. Okay. Since you know the P wave and S wave arrival, so you can also get what is the time difference. This time difference, as we told you, that it gives you the how the earthquake epicenter is from your station record in terms of degree, and you can multiply with the 110 kilometer per degree, you can get here what is the distance. You can see the P and S wave difference and the distance this one. Okay. So, by connecting these two, if you connect this, you will get a magnitude, or you can use the equation where you will get a magnitude. So, finally, based on this kind of explanation, so the magnitude ML can be estimated using this functional form. Okay. So, where the amplitude of earthquake goes and the time difference and distance is also accounted with some kind of vectors. So, you can see that it is in the log of 10. So, the log of 10 means that the earthquake magnitude of 6 is 10 times larger than the earthquake magnitude of 5. Okay. So, the earthquake magnitude of 6.2 is actually 20 times larger than the magnitude of earthquake magnitude of earthquake magnitude of 6.2 is actually 2 times larger than the magnitude of earthquake 6. Okay. So, 0.2 it is, but it is 2 times. So, the 7 means it is 10 times. So, that is what the log base 10 here indicates. So, this is how the people started quantifying the earthquake based on the recorded data. You can see this is actually a typical earthquake and death toll and the Richter magnitude estimation and the Mercalli intensity. You can see that the intensity of 11 was reported for the 2,50,000 people, and then the 10 was reported for the 3,16,000 people. Okay, so even though it is a function of the damage, but you can see the difference. So this kind of ambiguities now can be minimized when you have the quantified way of your seismic signal, and which is further used for the getting this one. So you can see the 1-to-1 comparison between the Richter magnitude and typical maximum Mercalli intensity scale. You can see how much it is coming. Okay. So this is the typical comparison of the from the past earthquake. So other than Richter, there is another magnitude developed which is also called local magnitude. Why it's local magnitude means you can use generally the seismic record in the regional network will have the P and S wave as a major component. Okay, so those kind of local data will be useful, or regional network data, that's why it is called as a regional magnitude. So the analog paper or film recording have limited dynamic range. So this record often clipped for the strong or even medium magnitude local events. It makes magnitude determined from the effects impossible. So when you use your analog paper and all, those days what happened, due to the paper limitation and all, you don't sometimes record a highest peak which is happening in the site. So those cases using of those kind of Mmax for the local magnitude determination is problem. So they come up with the alternate magnitude, that is called as a MD. So the MD is basically duration magnitude. It's based on the signal duration. It is almost routinely used in the micro earthquake survey. Okay. So it's called as a MD. So the another one they used was a micro seismic magnitude. So which is M, capital M and small ms are particularly important for the analysis and statistical treatment of the historical earthquake data. So three are the three main ways to compute the MMS are available, but these are all the scale only used at a selected place, not universally accepted. Only the ML magnitude is universally accepted, many people use. So now you know that why the Richter intensity or Richter magnitude is reported. So it has to be told the local magnitude or Richter magnitude. There is no quantification called Richter intensity or intensity in the Richter scale. Those are all basically wrong description of the earthquake size. So here we have seen that when there was a deep and far away earthquake, so okay, so the local earthquake you will get a P and S wave dominant. If it is the deep and far away earthquake, you will not get P and S wave as a dominant measurement in the same seismic station. So those places basically they need to go for the alternate way of magnitude estimation, where the concept of teleseismic magnitudes are come into picture. Okay. So there are two teleseismic means the waves are travelling from the very far distance, like a body wave and a surface wave. So you can see the typical time lap and what was the surface wave arrival. You can see basically the surface wave arrival here. See how much it is. So this is the your MB. So some places where you will get MB as a predominant, some places you will get MS as a predominant, depends upon the your location and where the earthquakes are occurring. That is what we have seen in the wave propagation. So the surface wave magnitude basically it uses a surface wave of the earthquake record. So the Richter local magnitude does not distinguish between the different type of waves. At a larger distance from the epicenter, ground motion is dominated by the surface wave. The Kuttenberg and Richter, okay, it's basically a student of Richter. In 1939 developed a magnitude scale based on the amplitude Rayleigh wave. The surface wave MS is equal to log A plus 1.66 log 10 delta plus 2. Assume that 20-second period. A maximum ground displacement is in micrometer. Delta is the distance seismogram in the epicenter in degree. Surface wave magnitude used for the shallow earthquakes. Okay. So this is estimated from the surface wave record of the particular place. So it is measure of amplitude LR waves, basically the Rayleigh wave for the 20 seconds. Wave length is about 60 km, which are commonly very distance earthquake and where the epicenter is located more than 2000 km. So used for the larger earthquake, cannot be used for the characterized deep and relatively small and regional earthquakes. The relationship between the amplitude A and period T and distance delta and MS given by this relation which can be used to estimate a magnitude of the particular earthquake using the surface wave. So, the next is the body wave magnitude. So, it just says that it is a basically estimated from the using body wave amplitude. So, as we have seen that the amplitude of P wave are not strongly affected by the focal depth, the Gutenberg developed a magnitude scale based on the amplitude of the first few seconds of P wave, which is useful for the measuring the size of deep earthquakes. So, the body wave magnitude MB is equal to, this is the function they use. So, this is the amplitude and delta is the distance seismogram from the epicenter in degrees, and these are all the T and 5.9 as a constant. So, using this you can get a MB can measure distance event, epicentral distance are less than 6 and P waves are not affected by the depth of energy source. So, commonly used in eastern North America due to the deeper earthquakes in that region. Magnitude MP is related to the amplitude of A and period T and P wave as follows. So, this is basically the relation between the A and T and delta T. So, this will give you the MB magnitude. So, if you sum earthquake, if we estimate, so now we studied ML, MB and then MS. If we estimate all three for the same earthquake, does it will be similar or different? Obviously, it may not be similar, as this considered the wave amplitude depends upon the location of the place. So, you will get a shadow zone and non-shadow zone, and then wave amplitude as a greater or smaller. Okay. So, that is what it will give you. So, this has been noticed by the scientists, why the scale are not same. Okay. For example, the Turkey earthquake MS is equal to 7.8, MB is equal to 6.3. Okay. So, then the Taiwan MS is equal to 7.7 and MB is equal to 6.2. The distance correction factor for amplitude depends on the geology, and deep earthquake do not generate large seismic waves. So, MS is biased load for medium earthquake. Some of the earthquake last longer than the other, even though the peak amplitude is not a same. So, this kind of phenomena where the magnitudes are not similar, this because of the there is a saturation of the wave. So, if you find the magnitude from the saturation, this kind of magnitude which does not go beyond some limit is called as a magnitude scale saturation. This means that there is a upper limit of the magnitude no matter how large the earthquake is. Okay, if we consider ML, MS, MB kind of measurement. Further instant MS surface wave magnitude never gets above 8.2. So, the MB seldom gives value of 6.7 in saturation. B must be measured in the first 5 seconds of the rule. So, this is the typical seismogram where you can see basically the MB measured here and then followed by the MS and then as well as the surface wave amplitude. Using this data you can estimate here this one. So, if you plot the magnitude versus the measured data, you can see that the MB saturate at a value of 6.7. Similarly, the MS saturate at a magnitude of 8. So, beyond 8 you will get a same MS irrespective of the site distance and the site condition and wave what you record, because that is the problem. So, similarly 6.7 also for the same kind of issues we can expect in the magnitude. So, this kind of phenomena after some value the magnitude is constant, that kind of phenomena is called as a magnitude saturation, which is called as a magnitude saturation. That means, up to some extent the value keep increasing, beyond some that particular extent the magnitude remains constant irrespective of the your amplitude and time. So, why the magnitude saturation happens? So, the amplitude of the seismic waves radiate at a particular period is related to the what happening at the source over a distance comparable to the wavelet. If the wavelet is long compared to the size of the source, the amplitude of the wave will express simple integration of the effect of the earthquake source deformation. If the wave length is short and compared to the size of the source, the amplitude of the wave will reflect the details of the rupturing process. So, these are all the reason why the saturation is taking place. So, in general the small earthquakes rupture relatively small area, therefore, amplitude of the short period signal yet to be yield a good measurement of the seismic source. So, the large earthquake rupture relatively large area where only the largest wavelength yield a good measure of the seismic waves. So, when you measure a estimate a seismic magnitude, you should be aware all this information which will help you to estimate a reliable magnitude for your site and earthquake, and that will be does not vary with respect to the time of the scale. So, but still this MB and MS are useful. Yes. Why? Because many or most of the earthquake are small enough that saturation does not occur. We have seen that 6.7 for the MB and 8 for the MS. So, if you have the less than that, your magnitude will remains similar, there is no kind of saturation or quarantine is required. So, the empirical relation between the energy released and MB and MX exist. So, the most earthquakes are small enough which can be measured in these two scale, and the empirical relation between the MB and MS is exist. The ratio of MB to MS can be indicate whether the given seismogram is from an earthquake or nuclear explosion. So, you can differentiate this is the artificially created seismic signal such as a blasting or nuclear explosion, or it is a seismogram recorded data. So, such kind of things can be arrived when you have the MS and MB. So, and also the MS will be used to estimate a energy from the earthquake, because there is a direct correlation between the MS and M energy in the literature. So, these are all the applications where MB and MS still are useful. So, anything better which can record the earthquake? Yes, the scientists are gone through this one and try to update and then come up with the new concept of magnitude which is based on the fault moment at a particular place. So, the seismic moment which is called as a M naught. So, invented in 1916 to circumvent the magnitude limitation. So, as a physical unit of energy like Newton dyne centimeter or Newton meter, this is the product of three factors that indicate size of the earthquake. So, the moment at a particular place equal to the stiffness and rupture area and slip offset. So, basically if this is your fault, so due to the up and down forces, so you can get a moment. So, which is the function of your shear modulus. So, this is the function of the material shear modulus, okay. Then the how much it breaks and ruptures, and what is the offset it creates, the slip. So, if you knowing this, one can estimate what is the seismic moment M. So, if you know the seismic moment, you can estimate a moment magnitude. Okay. The seismic moment is basically the measure of relative length of the shaking locally. The earthquake magnitude provide measure of size on bias of the wave motion. The peak values used in the magnitude determination do not reveal overall power of the source. The measure of quake size related to the leverage forces couples across the fault slip provided estimate overall size of that will be estimated, that is called as FL is called as a seismic moment. That moment is used to estimate a magnitude, that magnitude is called as a moment magnitude. So, the moment value are used to determine the moment magnitude, the MW equal to 2/3 of log M naught minus 10.73 when M naught is dyne for, you can see that it is a dyne for the dyne centimeter. So, if you use some other unit, basically you will be getting a different equation. You can see these constants are changing, you can see here and you can see here. Okay, this is the Newton meter, that is on the dyne centimeter. So, the moment magnitude provide measure of the dimension of the entire slip of the fault and maybe hundreds seconds in the kilometer length. Seismic wave used to estimate MS is in contrast have the wavelength of close to 100 km for the moderate to large earthquake. Such a wavelength will sample only part of the entire fault. So, MS become a saturated and at same upper threshold value. So, by comparing the Loma Prieta earthquake, so you can see the MS is so much, MW is so much. Okay. So, this is the difference you can estimate, but to measure the moment you need to know what is the rupture length of the fault. So, the magnitude, so overall whatever we discussed, so we can see that the magnitude is measure of the ground shaking amplitude, okay, which is the function of basically how much the amplitude the earthquake has been reported, like this, okay, how much the amplitude is reported. That amplitude value is your magnitude, will say it may be the P or it may be the S or may be the surface wave, depends on. So, the more than one magnitude scale are generally used to quantify the earthquake, depends upon the development taken place. All the magnitude scale have the same kind of algorithm form. If you observe the equation, all of them is the function of log 10 base. So, which indicate that one magnitude like 5, 6 is, even though number wise it is only one increment, but if you say earthquake magnitude 5 and 6, okay, which is 10 times larger and smaller. For example, the 4 magnitude is actually 100 times smaller than the 6 magnitude, and similarly 10 times larger than the 3 magnitude of 4. So, such kind of amplitude log difference has been in the, that is why it is used here log 10 base as a magnitude estimation. So, since the different scales are used in different way, different period of vibration, they do not always give a same value, which we have seen in the some of the example. So, in summary, the local magnitude developed by the Richter, which is indicated by ML, which generally uses S or surface wave, the maximum component of these 3 wave for a period of so much. The body wave indicated by MB and uses only the P wave, and only the period they use was 12 seconds. Surface wave MS and Rayleigh wave is generally used so much. Moment magnitude MW, rupture area and slip, this is the period, the data what they use for the assessing that. Okay. So, among these magnitudes, basically the moment magnitude is more reliable way of getting the earthquake measurement. So, the earthquake difference size and energy releases may have the same earthquake magnitude. So, the San Francisco, California and Chile earthquake has been taken, and both event basically measured MS of 8.3. The fault rupture area of Chile earthquake is actually 3 times greater than the California earthquake. So, different fault rupture length correspond to the different amount of energy released. So, the MW accounts extent of the fault rupture. So, the MW for the San Francisco earthquake is actually 8 and Chile is 9.5. The magnitude scale do not increase monotonically with the earthquake size. Okay, that was the observation from this we can say. So, the MW is the most reliable scale. So, as on today they use. So, since it was this one, there is a old, all the old scales are being converted and there is a conversion for that. So, this is the different magnitude, moment magnitude, this is the different magnitude. You can see here the magnitude of ML up to magnitude of 7, it is no saturation take place, but after that there is a saturation. So, MB saturates at a 6.7, you can see here. Okay, so, the MJB magnitude Japan, so long period measurement earthquake. So, you can see here, and then this is the M minus MS, okay, this one, and M moment magnitude does not saturate with the earthquake. So, the moment magnitude can be find out for the any earthquake. For the shallow crystal earthquake, Bolt suggested that MD and Coda length magnitude less than 3 can be used, shallow crystal. So, either ML or MB for the magnitude between the 3 and 7 will be fine. So, the MS for the magnitude between the 5 to 7.5. Richter scale stops increasing after the magnitude 7. Magnitude MB and MS saturate at above 6.5 and 8.5. So, MW does not suffer from saturation. So, the problem in the practical range is magnitude 2 to 10. Okay, the intensity magnitude relations are available, where you can convert intensity as a magnitude, magnitude as a intensity. So, those data are really useful for the your prediction of the earthquake hazard. So, this is about the earthquake magnitude. So, during the earthquake magnitude we also discussed about the energy. So, the energy means basically the amount of energy released due to the breaking of the fault. So both magnitude and the seismic moment are related to the amount of energy that is radiates from the earthquake, so which we will discuss in the next class. So today class we have seen about the magnitude and then different type of magnitude scale, how you can quantify the magnitude. So we have noticed that all the magnitude is the function of log 10 base. So that means one magnitude is greater than 10 times, okay. So smaller or larger depends upon the which number it comes, okay. So that is what we have seen. So this energy is a function of the wave what you are seeing. So how to estimate the energy, what are the energy content in the previous earthquakes are reported, what are the nuclear explosions are taking place, and how that energy was there, we will discuss in the next class. So with this I thank you for watching this video. So we will meet in the next class. Thank you very much.